Stamitalks.
My name is Mark Schleiser. Welcome to this first episode of Stamitalks, fertilizer technology. That's what we are going to discuss in this podcast. And our first guest is Pejman Djavdan, CEO of Stamicarbon. Welcome, Pejman.
Thank you very much, Mark. Honored to be here.
Glad to have you. You've been with Stamicarbon since 2005, CEO since 2009. How have the experiences been so far?
It has always been interesting to work within Stamicarbon because the industry is changing and therefore we are adapting to that. And it makes it possible for us to look at the possibilities, how we can best serve the industry and how we can best serve mankind as a whole.
Okay.
We play an important role in that, because of the importance of the food and food security worldwide. Therefore, Stamicarbon plays an important role.
Okay. What does Stamicarbon do for our listeners that don't know?
We are a technology company. So we continue to develop new technologies for agriculture, mainly for fertilizers, for intensification of agriculture. And our focus is, of course, to do that in a way that it does not impact the environment. So we call it intensification in a sustainable way.
Okay. And so usually I think people who hear about intensification of agriculture, they're thinking about pollution.
Mm-hmm.
How would you do that in a sustainable way?
Well, first of all, let me tell you, it is important to continue to intensify agriculture because we are growing as a world. The whole population is growing. Therefore, it becomes very important to be able to feed the world. So intensification is a must. However, we need to do that in a way, as I said already, that it does not impact the environment. How to do that depends on the different ways that we are working with fertilizers worldwide. Stamicarbon is focusing on two areas. We are focusing on, first of all, how can we best produce fertilizers in a way that is sustainable, it does not have impact on the environment. And secondly, of course, on the use of fertilizers. How can we use fertilizers in a way that it has no impact on the environment?
Okay, that's interesting. And if you talk about sort of the fertilizers, then would mostly be used by farmers, I assume. Yes. So that's the use of fertilizers.
Mm-hmm.
Is that something that is the same all over the world? Is every farmer using, because I think you can have organic fertilizers, you can have mineral fertilizers. I think there are multiple types of fertilizer.
Mm-hmm.
Do they all have the same environmental impact?
Well, the environmental impact of the fertilizers, we are talking about nitrogen fertilizers. So in our case, we're talking about adding nitrogen to the food cycle, which makes it actually possible to produce amino acids. That's the main basis for production of food. And the nitrogen fertilizers, nitrogen is a substance that can have impact on the environment if it is not used properly. So the main thing is that when you use nitrogen fertilizers in any form, it doesn't matter in any form, it could be organic, it could be mineral fertilizers, in any form, if it is not taken up by the plant, then it's lost to the environment. And when it is lost to the environment, it has impact on the environment, both on the air, but also on the water. So the most important thing when using nitrogen fertilizers is that making sure that everything that you use is actually taken up by the plant. And that is one of the areas that we are working on. So then you are focusing actually your question on the area of the use of fertilizers.
So how does this work? So you place fertilizer on the land.
Yes, then, one possibility, yeah.
And then the plant absorbs it, but apparently, if you put too much fertilizer on the land, then not something goes to the groundwater or into the air. That's what you explained.
Yeah.
Typically, we'll think it will be different per region, I assume. But what a percentage could be that would be absorbed by the plant currently? Can you say something about that?
Usually, depending again on the practices of the farmers, because if the farmer is able to put the fertilizers at the right time, the right amount, the right sort of fertilizer, and also the right place, which is what we call the 4 Rs, then the fertilizers is taken up mostly by the plant. So it's also depending on the practices of the farmers. And there is a lot of work going on worldwide to make sure that the farmers are educated so that it is done in a way that it's not impacting the environment. However, there are also ways of making the fertilizer itself much more controlled release, or in a way that it's better and is releasing the fertilizer only at the time when it is needed by the plant.
Okay, and how do you do that?
And that is the area where Stamicarbon is working on, for example. So what we are able to do is to coat the fertilizers in a way that it becomes what we call controlled release fertilizers, so that it is releasing the fertilizer at the right time and with the right amount when it is needed by the plant. This is just one of the technologies that we are working on. So as I mentioned, we are working on production of fertilizers based on renewable resources. That's one area. The other area is the use of fertilizers. Yeah. And the use of fertilizers is important to look at two things also, to make the fertilizers more efficient, but also more effective. So when you talk about making the fertilizers more efficient, then one of the ways of doing that is to use a coating to make the fertilizer what we call controlled release. This is a permeable coating, of which the permeability is dependent on temperature and on humidity. And therefore, you can almost program the coating in a way that the fertilizer is released to the plant when the plant needs it.
Okay, so if you have a very humid environment, for instance, then you apply a bit more coating, so it's the nutrients get into the plant later.
But so it has to do with the humidity, with the temperature, also where the plant is growing. So depending on the type of the plant, you can also program the fertilizers in a way that for that specific type of the crop, it is released when the crop needs it.
Okay, and then how do you know? I think there will be agricultural studies that know or say when a specific crop needs a specific fertilizer.
Yeah, so you need to, of course, know the agronomics of the plant, and based on that agronomic, you can design the coating and apply the coating to the fertilizers in a way that it's programmed for that specific crop.
Okay.
And this then leads to much more efficiency. Currently, on average, when we use fertilizers, only 50% of the fertilizers is taken up by the plant.
Wow.
The other 50%, this is average, average number. The other 50% is lost to the environment, either going through nitrification to the air, or it is lost to the water and then has impact on the water quality. Therefore, we are working on this coating, and with this coating, actually, we're able to increase this efficiency to about 90%, which is a significant increase, significant improvement. And we hope that this is going to be used more and more worldwide.
Yeah. It's going to be used more and more. At least that's the hope that you speak of. What's the percentage now globally? What amounts are we talking about? How much fertilizer is used globally on an annual basis, and how much of it is, let's say, controlled release or coated fertilizer?
Yeah, so again, I'm only focusing on the nitrogen fertilizers because there are many different types of fertilizers. So on the nitrogen fertilizers, we're talking about worldwide 200 million tons of nitrogen fertilizers being produced and being used. And it's only 1% of that currently, which is controlled release.
There's a lot of room for improvement.
So there is a lot of room for improvement indeed, yes.
Okay, and is that because we'll get to the producing part of fertilizer later? But so in applying, is it adding a coating, making it controlled release? Are there other sort of tricks and tips that you are thinking of, or what are possible to do to improve the efficiency and effectiveness of fertilizer?
Yes, there are many other ways also to improve the nutrient efficiency of the use of the fertilizers. You can add nitrogen inhibitors that are making the release of nitrogen slower. There are many other ways of doing these things. Stamicarbon is working only on the controlled release fertilizers because we think that is the best way of controlling the release of the nutrient to the plant. Another area that we are also working on is to work on the making the fertilizers more effective. And then I'm talking about adding micronutrients to the fertilizers, because especially nitrogen fertilizers can be used as a carrier of micronutrients, because the amount of nitrogen fertilizer that we are using is, of course, much higher than any other type of fertilizer. Therefore, adding a little bit of other micronutrients is possible because the amount is high. So,
what's the added value of doing that?
Yeah, so micronutrients. Humans need vitamins. We try to take it up by eating a good food.
Yeah, or some pills could also be.
Sometimes we also have to. Actually, the reason why we have to take pills is because the food that we are taking is becoming less and less effective because the ground that the crops are made on and being produced on is also losing its micronutrients. So you can do two things: either take vitamin pills or add micronutrients to the plants. So we are at Stamicarbon, we are looking at the possibility of adding micronutrients to the plants, which makes the plants and also the food that will be produced based on those plants much more richer.
So if I take a vitamin pill, I take vitamin A to Z, but then so I don't even know what those letters are. I think Z is for zinc, but
it is actually.
So, but then what type of nutrients would you add to the to the ground?
Zinc is one of them.
Okay.
So half of the world's agricultural land is deficient in zinc. So we think adding zinc, it would be very important. And that's also something which many people know from the industry. So there is a lot of work currently in adding zinc to the fertilizers, but also copper, iron, silicium, many other elements that are needed also for humans, but also for plants. These elements are needed, magnesium, these elements are needed for the growth of the plant itself, but also to make the food that we make from the plant more healthier for us.
And then that might be nice bridge to producing fertilizer, right? So then you have zinc somehow, somewhere, and you need to mix that with nitrogen-based fertilizer.
Exactly, yeah.
How do you do that?
Well, one of the ways that we are working on within Stamicarbon is what we call slurry granulation. So it is possible to add micronutrients into the last stage of the production of fertilizers, which is the solidifying stage, which is then the granulation stage that granules and makes the granules from the melt of fertilizer, of nitrogen fertilizer.
So you have liquid fertilizer to start with, and then you mix some nutrients in the liquid.
Exactly.
And then you make it solid into a granule, and that's what you sell to farmers.
Yeah. And that's what we call slurry granulation, and that is one of the ways of doing that. And we have a very good technology for that within Stamicarbon.
Okay. And is that something, because that you said it's the last phase of the production? Can you sort of high level, what are the different phases of nitrogen fertilizer production, and in those elements, what are the ways to improve the sustainability?
Very nice question. Yes, I mean, if you look at currently how we produce fertilizers, mainly it is produced based on natural gas. So now I'm talking again about the nitrogen fertilizers. So nitrogen fertilizers are produced using natural gas going to ammonia, and from ammonia to urea or to nitric acid, ammonium nitrate, and then from that, of course, into the end product. When we talk about using gas, then this is a way which is now currently being used. 70% of the nitrogen fertilizers worldwide is produced from gas. Yeah. When it comes to environmental impact, there is even a worse way of using or producing nitrogen fertilizers, which is using coal. 30% of the world's production of nitrogen fertilizers is based on coal. Mainly in China. So then you have even a coal gasification, going from the coal gasification into ammonia, and from ammonia to urea. Stamicarbon, as I said, is working on making the production of fertilizers, nitrogen fertilizers, much more sustainable. And the first step that we are taking in that is to, of course, currently, I could say we actually are looking at 3 stages and 3 steps to do this. First step is to make the current production of fertilizers, which is being done worldwide, more efficient, and reduce the environmental impact of that, reduce the energy consumption of that. And this we are doing by revamping, debottlenecking, improving the current urea plants worldwide. We have technologies that make this possible. We are, for example, able to reduce the steam consumption in a urea plant with 40% using our ultra low energy concept that we have already produced. We have already put into the market 12 years ago. And there are already 8 factories worldwide that are using this technology. But there are other ways also that we are looking at the possibility of reducing the current environmental impact and the energy consumption of urea plants. Also, we have introduced a digital monitor, which makes it possible for us to online help the plants, the factories, by reducing their energy consumption.
How does monitoring that digitally, how does that support sustainability?
Well, I mean, when you are able to optimize the way the plant is producing fertilizers, then you are able to reduce energy consumption. And that has impact on the sustainability. But as I said, this is the first step. So the first step is to optimize the current plants that are producing fertilizers. The second step is, of course, to look at how can we produce fertilizers in a way that no CO2 is released by production of fertilizers. And we have introduced already the way of production of green ammonia based on green hydrogen. So when you produce green ammonia based on green hydrogen, there is no CO2. So you have 0 CO2 emissions.
So you put a windmill or power plant or whatever type of green energy you have, and then you use an electrolyzer to get to the ammonia?
The way we are doing this currently is to use sustainable electricity, and it could come from indeed windmills or photovoltaic plants, but it could also come from thermal energy or any other sources that is sustainable. And then we use that through electrolysis to produce green hydrogen, and then you can go from green hydrogen to production of green ammonia. And we have the technology to produce green ammonia from green hydrogen.
Okay. And then, so this is new, we have the technology, you say. You were talking about current production of nitrogen-based fertilizers, 200 million ton per year.
Yes.
How much green fertilizers produced currently? Do you have any idea about it?
Again, it's less than 1%. So we're talking about, these are really new technologies that we are putting into the market. It takes time before it is adapted and it's going to be used. We expect that it takes 10 years before half of the current production capacity is going to be changed into green ammonia.
Okay, so if you look at all the sustainable, United Nations sustainability goals, net zero by 2050, is that achievable in your opinion?
Yes, it is.
If we're talking about fertilizer?
Yes, it is. Technologies are there. So it is a matter of adapting those technologies, using those technologies. From a technology point of view, these goals are achievable.
Okay, so then what's the bottleneck?
Well, I think economics, how we can actually start using these technologies, depends on also the incentives that the governments are putting in place for using these new technologies. It makes it possible to go into these technologies more rapidly when there are incentives put in place by the governments.
And do you see a lot of incentives already? Because
yes, there are something is coming up. I mean, we have the Inflation Act in US.
Inflation Reduction Act, yeah.
Yes, Inflation Reduction Act, indeed, which is making it possible to produce green hydrogen and get subsidies for that, but also reduce the amount of CO2 which is going to the air from the factories. And that's also based on this Inflation Reduction Act, they get incentives for doing that. And also I hear currently Europe is working on a similar act that is going to have impact also on the incentives in the industry.
Okay. And you were talking about, you started with 3 ways to make it more sustainable. You said about the production without CO2, with green ammonia, green hydrogen.
Yeah.
What's the third?
The third one, indeed, the first one was the optimizing current plants. The second one was to produce green ammonia and then go from green ammonia to nitric acid ammonium nitrate or calcium ammonium nitrate based on green hydrogen. The third way is something that Stamicarbon is currently working on, and that is in the R&D stage. And it is the production of the nitrate fertilizers based on renewable energy and renewable resources. So directly direct production of nitrate fertilizers.
Okay. So then how is that different from, because option 2, green ammonia is also based on green energy.
Yes.
This is also...
Yeah, so the number of steps is less.
Okay.
So currently you go from green energy to green hydrogen, and then from green hydrogen to green ammonia, and from green ammonia to nitrates. We intend to produce nitrates directly from, let's say, renewable resources and renewable energy.
Okay, but that's still, you say that's in R&D phase, so that might not work. And that's with
I
R&D,
mean,
you never know.
No, exactly. R&D, you never know, but it's important that a company like us continues to work on those areas to come with new technologies. So that's why, I mean, within Stamicarbon, we believe that we have a responsibility, we have a role to play. We are the market leader when it comes to technologies for urea and for nitrogen fertilizers. Therefore, it is our responsibility to make these technologies more sustainable and continue to make them more sustainable. So we are spending a significant part of our revenues, around 10% per year, on R&D and on innovation. We work with many companies around the world, partners, suppliers, customers. We have more than 60 projects to continue to develop technologies for sustainable intensification of agriculture. So we take our responsibility very seriously in that sense.
Of course, it's R&D. You hope for this. We're already talking a bit about 2030, 2050, net zero.
Mm-hmm.
You say at 2030, half of the global production could be based on, I think, an option 2, the green ammonia variant.
Depending on the pace of introduction of that and the... Potentially, yes.
Okay.
Potentially, yes.
So if you fast forward, but if you take a step back and think about that, the world population is growing. I think last year we had our 9 billionth inhabitant of Earth.
Was it 8 or 9?
Oh, I think
it was 8.
Oh, 8. Okay.
8, yes.
At least we're growing rapidly. I think that's that's the conclusion for sure.
Yeah.
If you would look forward, I think the projections are that I think by the end of the century we are hitting, I think 10 billion or
10 billion,
maybe
yes.
even 11, depends on some projections.
Yeah.
You say we cannot increase the amount of arable land.
Mm-hmm.
So we need to decrease emissions, be more sustainable. Are those two objectives reachable, or is it a paradox? How do you see the future?
Well, it is reachable. I mean, it is the technologies are there. Every time mankind, and this is something we have seen in the history of mankind very often. Every time we hit a border,
mm-hmm.
then we evolve. So we as a whole evolve. And we have seen many new technologies being coming to production. I mean, if you look at the Club of Rome in 1890 came with a report in UK that was telling that the number of people in the world could not reach more than 2 billion. That was the conclusion at the time, because there was no fertilizer. So they thought the amount of food that can be produced worldwide is enough only for 2 billion people. And then beginning of 20th century, 1905 or something around that, we were able to produce ammonia.
Okay.
And based on that, because of the production of ammonia, synthetic production of ammonia, we could increase the number of people to what it is now, 8 billion. Now, I think the big challenge that we are looking into is how can we sustainably intensify agriculture. So to combine these two, continue to intensify agriculture, but doing it in a sustainable way is the next stage of the challenge that we have as a mankind. And I believe there are technologies, and we can develop technologies to be able to do that. We need to only put our resources, put our efforts in developing those technologies.
Okay. And you say Stamicarbon is pushing this.
Yes.
You invest a big amount of resources in doing this. Do you see other parties in industry doing the same? Because I think this is not something that a single person or a single company can do by itself.
No, I hope so, yes. And we see, of course, also very good possibilities. We are looking at many startups worldwide that are focusing on in this area, and we encourage that. So also for Stamicarbon, it's good to collaborate with those small companies, with startups. When there are new technologies coming up, we look at those technologies. We look how we can best help those companies grow or collaborate with them. So yes, as I said, we have a responsibility, and we take that responsibility very seriously. We work with those companies. We have taken up stakes in a company in US, for example, in the controlled release fertilizers company, which is called Personal Agritech. We have taken up shares in that company. We acquired the company in digital services 3 years ago to be able to grow fast in our digital capabilities to help the plants. So we are looking in those areas as well. And we hope that there are many companies who are working in this area. And we see also those companies, and we collaborate with them.
Thank you very much. I think to sum up, I think you've explained about how I think to get the world to a more sustainable agriculture in general, I think you've described that farmers need some education, fertilizers need to become more efficient with coatings, but also more effective with micronutrients.
Mm-hmm.
And those are two important elements. And in the production, revamping existing plants with ultra-low energy and with digital, improving that. If you talk about new plants, you've said, well, let's look into the green ammonia, green hydrogen based fertilizer based on renewable energy, and also based on renewable energy, an R&D program which is a bit further down the road that might also skip a few steps and be even more efficient in producing. And I think what I like. What you say is the responsibility that Stamicarbon is willing to take.
Yes, yeah.
And the collaboration that you're seeking with partners. So I think that's an optimistic note to the future. So whenever we hit the 10 billion, the world should be ready.
Yes,
so,
I am optimistic about the future. As I said, I think mankind is able to adapt itself and to come with new technologies so that we can continue to have a world that is ever lasting and continuing to have an environment where we can work together.
You don't often hear a CEO talk about mankind, so that's also I think that's also a hopeful sign.
Yeah.
Oh, thank you, Pejman. Maybe
thank you very much, Mark.
We'll have to you on another time on this podcast. Next time we are planning to do, of course, something about fertilizer technology. Mm-hmm. Could be about corrosion or process, or we'll have a whole series of podcasts coming up. So we'll be back for sure. Thank you.
I for sure will be listening. Thank you.
Great to hear. Thanks.
Stamitalks.